Now that we've had a look at the atom's development, we've seen all the key experiments that have happened as scientists have discovered it. We also know that when we built an atom for ourselves, we had a balancing number of protons and neutrons. However, this is not always the case. The periodic table tells us that there is 118 elements on there. But what we actually have found is that there are 266 stable nuclides. Now, nuclides is just the plural of nucleus. So there's 118 elements, but there's 266 different versions around there of all of these 118 elements. Because we've got such a large range of stable nucleus, we've had to label them in different ways. First, we've got isotones, then we have isobars, and something everyone's probably a little bit more familiar with is isotopes. And that's what we're going to be focusing on, but we still need to know what isotones are and isobars are. Now, isotones, they have the same neutrons, but different protons. An example of an isotone would be silicon and phosphorus. They have the same number of neutrons, however, they have a different number of protons. Isobars have the same mass, but different protons and neutrons. An example of this would be argon and calcium, which have the same mass, but the different number of protons and neutrons. And finally, we have isotopes. They have the same number of protons, but different neutrons. An example of this would be hydrogen and deuterium and tritium, where hydrogen has no neutron, deuterium has one neutron, and tritium has two neutrons, with a total of 3 in the nucleus. We're going to be primarily dealing with isotopes, but it is still good to know what isobars and isotones are. Now that we've had a look at our different types of atoms that we can have, let's ask a question. What is the most stable form of an atom? Is it when the electrons are equal to the protons, the neutrons are equal to the electrons, or the protons are equal to the neutrons, or just none of these in general?